Hello students, today we will discuss shift registers. Shift register is a memory, but it is not a bulk memory. Instead, we will use a shift register to store a binary word of fixed length. A shift register can store a binary word. A binary word means it has a few bits. For example, a word with 4 bits or a word with 8 bits, and we can store such binary words in a shift register. According to the length of the word, we should have a shift register of suitable size or length. And every shift register is a clocked circuit, and its operation is based on clock pulses. And the important feature of a shift register is that the data stored or the bits stored inside a shift register can be shifted either towards left or right. And the basic building unit of a shift register is a D flip-flop. We already know the functioning of a D flip-flop. It is basically a JK flip-flop in which its J and K terminals are connected together, but one input is given through a NOT gate, and that flip-flop produces output similar to its input, or its output will be the same as its input, but there will be a delay of 1 clock pulse. That's a D flip-flop, and that D flip-flops are used here to construct a shift register. A n-bit shift register has n D flip-flops. We have basically 4 types of shift registers. The first one is serial in, serial out. As the name says, the serial in means the data can be inputted to this shift register serially, or the bits can be entered in the shift register one by one. First of all, we will be entering the first bit, then the second bit, and third bit. In that way, sequentially in time, we can enter the data bits into the shift register. That is the meaning of this serial in. What is serial out? When we store a data in a shift register, we need to read the data after some time. So what is the data stored in the shift register? That data has to be read out after some time according to our need. So at that time of taking the data back from the shift register, we are following the method of serial outing. Serial outing means the data bits stored in the shift register will be read out one by one sequentially in time. All the data bits cannot be retrieved from the shift register simultaneously or at a single instant, but rather we will be taking the output bits one by one sequentially in time. That is the meaning of serial out. And the second type of shift register is serial in, parallel out. Here, as we already said, data bits will be entered serially, but here the difference is that the data reading is made parallel, or it means that all the bits stored in the shift register will be retrieved simultaneously in a single instant. So that is the meaning of parallel out. So here reading of the data is fast. With a single instant, we can read out all the data bits stored in the shift register. That is the importance of this parallel out. And the third type of shift register is parallel in, serial out. Here, the data entering is not serially in time, but all the data bits will be entered into the shift register in a single moment. So we can give all the input bits simultaneously into the shift register. So data entry into the register is very fast, or it will be completed within a single moment. And here the data retrieving is serially. That is the meaning of serial out. Data bits will be read out one by one sequentially in time. Is parallel in, parallel out. Here, as the name indicates, the data entry is parallel, or all the bits will be entered in a single moment, and similarly all the data bits will be retrieved parallelly or in a single moment. So all the data bits will be available at the output in a single instant. That is the meaning of parallel out. So in the case of serial entry, we will take some time to complete the entry of the data bits. But when we enter the data bits in parallel, with a single moment, we can enter all the data bits. But to make the entry parallel, we must have the required circuit. So the most simple circuit is that of serial in, serial out. When we enter the data in parallel, we need some circuit. Similarly, when we need to read the data parallel, we need more output pins from the shift register. So to enter data bits serially, we need more pins to the IC. Similarly, to read out parallelly, we need more output data pins. But in the case of a serial in, serial out shift register, only one input pin to enter the data. Similarly, to read the data from the shift register, we need to have only one output pin for the register. So that is the simplicity associated with the serial in, serial out shift register. But here the disadvantage is that for both data entry and for data retrieval, it takes longer time since we are doing the operation serially in time. So next we will see a serial in, serial out shift register, and it will be termed as SISO. It indicates serial in, serial out. So we will use this abbreviation SISO register. And here this is the example of a 4-bit shift register. It can store 4 bits inside this register. As we already said, this register must have 4 D flip-flops since it's a 4-bit one. And we have shown here the first flip-flop is FFA, second one is FFB, then FFC, and finally it is FFD. And we have to note the connection done here. This is the input pin for the entry of serial data, and this input pin is the D input of the first flip-flop and its output QA. QA is the output of the first flip-flop FFA. So the output QA is then connected to the D input of the second shift register, and its output QB is connected to the D input of the third register, and its output QC is connected to the D input of the fourth D flip-flop. This is the way of connecting, and the clock pulse is connected to all the 4 flip-flops separately. So when we apply a clock pulse, the pulse will be reaching the clock input of all the D flip-flops at the same instant. And to take the data out from the shift register, we have this output pin, and that output pin is the Q output of the last flip-flop. So this is the connection. Now we will see an example of entering the data 0101 into this register. So for that data, this is the data 0101. This is the LSB or the first bit, and this is the most significant bit MSB or the last 4th bit of the data. So when we enter this data serially, we will first enter this LSB to the flip-flop that we will see now. So here this LSB, this one has to be entered here. It will be given at the input D of the first flip-flop or at this point. And before entering, at first we will clear all the flip-flops. So the output of all the flip-flops are zeros now. You can see here QA, QB, QC and QD all are zeros. And so the register is in the cleared state, and now we will be entering the data 0101. So for that, first of all, we have to enter this one here and then apply a clock pulse. So when we apply the clock pulse to a D flip-flop, whatever be the data at its input will be shifted to its output. So let us look at the application of the first clock pulse. So we have applied the first clock pulse. So this one, the first bit 1, which was given at the D input of the flip-flop A, so that one will be going to its output. So it reaches to QA after applying the first clock pulse. So the previous 0 at this point will be shifted to this point, and the 0 at this point to this point, and the data at this point might have shifted to this point. So when we have applied the first clock pulse, the first bit is reaching to this point and it is stored at this point. And then we will apply second clock pulse. So after the second clock pulse is applied, what happens is here was the one initially. This one was here before the second clock pulse is applied. And when we applied the second clock pulse, the one at this point will be shifting to this point, the output of the second flip-flop. And the 0 applied at the serial data input point shifted to its output, or it reaches here. So this one is now here and this 0 is here. So these two bits have been entered into the shift register after the application of the second clock pulse. Next we will be applying the third clock pulse, and after applying the third clock pulse you can see this bit 1 which was given here. After the application of the third clock pulse, this one will be shifting from this input pin to this point. So that one, this one reaches here, and the 0 which was here earlier has been shifted to this point, and the 1 which was here earlier now shifted to this point. So these three bits 1, 0, 1 has been entered into the register. That can be seen here 1, 0, 1. Now we have to apply one more clock pulse, that is the fourth clock pulse. After the application of the fourth clock pulse, this 0, the final 0, is reaching to the output of the first flip-flop, and the 1 which was here now shifted to this point, that is this one of the input reaches here, and this 0 you can see here, and this one is here. So all the 4 bits 0, 1, 0, 1 has been entered into the shift register and can be seen here 0, 1, 0, 1. This is the way we are entering all the 4 bits into this shift register, and for the entry of these 4 bits we had to apply 4 clock pulses. So this is the way of storing a data word in a shift register. And then after entering a data into a shift register, how we are going to read those data from the register. So here we are reading the stored bits serially from this output pin. So this output pin is the output queue of the last flip-flop. So you can see the stored bit, that LSB of the input data stream is already available here. You need to just read out from this point, and this 0 is not available at the output. So if you want to make this 0 bit available at this point or output point, what we have to do is apply one clock pulse. When we apply one clock pulse, this 0 will be shifting to this point. So after reading this one, we have to apply one clock pulse so that this 0 will be reaching at this point or output point, and then we can read that 0 from here. And to get this one, we need to apply one more clock pulse. So this one will be reaching here and we can read that one. And to get this 0 at the output, we need to apply one more clock pulse so that this 0 reaches here. So in this way, all the 4 bits stored in the register can be made available at the data output. This is the way of reading the data stored in a shift register. So hope that you all have understood the operation of the shift register. It's the data storage or data entry and then the data retrieval. So now thank you.